In this video, I want to talk about the foundation of using substitution as a method of solving linear systems. So in order to effectively use substitution, you need to be comfortable substituting not only numeric values, but also algebraic expressions into other algebraic expressions. So we're going to go ahead and look at two examples. The first will simply use numbers, so this will be numeric in nature, and in the second we'll be substituting values that include variables. Okay, so the big takeaway here is that whenever we substitute anything, we always have to put it in parentheses. So we have this expression 5ab squared minus 3ab divided by 10. So 5 times a, the value of a is 5, I'm going to put that in parentheses. And then b squared, so b is negative 2, put that in parentheses with the squared. Then minus, and we have 3ab, a is 5, b is negative 2, again putting everything in parentheses because it means we're going to end up multiplying these things. So now, numerically, we're going to go ahead and use the order of operations to kind of evaluate or simplify this expression. So I can do my exponent first, and I get 4. So 5 times 4, and then I can work the multiplication in this numerator. 3 times 5 is going to be 15, times negative 2 is negative 30 over 10. Okay? So I have the subtraction with a negative, so I'm going to go swoosh swoosh and make that an addition. So 5 times 5 is 25, times 4 is 100, plus 3 will be 103. All right, so once again, the big takeaway. When you substitute values, whether they're numeric in nature or whether they are variables, you will always use parentheses in that substitution process. In this second example, we have this expression, negative 6a plus 11b, and we know that a equals this expression that contains a variable x, and b equals this expression, again, that contains the variable x. So we're going to substitute these expressions in for these variables, but in this case, we won't have a number at the end. We're just going to have another algebraic expression. Okay? This actually has a lot of applications and use later on in algebra. So let's go ahead and take a look at this. So negative 6a. So what's my value of a? Well, 3 minus 4x plus 11b. What's the value of b? 2x plus 9. Notice, if you will, again, we put those things in parentheses. So substituting always requires parentheses because it means multiplication. So I'm going to go ahead and distribute through here. So negative 18 plus 24x plus 22x plus 99. So now I'm just going to combine like terms. So the x's can go together. 24 and 22 makes 46x. And then negative 18 plus 99 will make a positive 81. So 46x plus 81 is the algebraic expression that I'll have whenever I substitute these values of a and b into my initial expression.